Cool. So how many of you guys were here for Tyler's great talk right before mine on Async 08? Awesome, great. So you guys are going to be double Async 08 masters. That's going to be fun. He gave a very good talk right beforehand discussing Async 08. So I'm just going to go up here and give my own perspective as well. Hopefully you'll benefit from both. So before I get started about like what I'm going to be talking about, let me just give a quick overview of what Async 08 is in my mind. So it's a new syntax that was introduced formally as part of the JavaScript language spec this year in 2017 as part of ECMAScript 2017. And it was also introduced in Node.js 7.6.0 without, it was available in Node before that with a flag, but now with Node 7.6 and Node 8 later, it's now available without a flag, so you can just use it in your Node scripts without any polyfills or transpilers. So async await is actually two distinct keywords. An async function, which is a special type of function that always returns a promise, and await is a keyword that pauses execution of a function until a promise is settled, or until it resolves or rejects. I'll talk a little bit more about the difference between those two in a bit. But so that sounds a little bit abstract. What does that look like in practice? So how many of you here are familiar with the fetch API? So fetch is a kind of browser-based / isomorphic tool for making HTTP requests. So if you want to hit a REST API and get back some data, you would use fetch. Fetch is more popular in the browser than Node, but I figured I would I would use it for my kind of Node-based presentation in order to be more friendly for the front-end devs out there. So node fetch is going to make out this HTTP request to this URL, http:/bin.org/ip, which, if you've never seen it, basically just gives you back a JSON object that shows you your IP address. So this is one way you can get your IP address. But so you see there, this printMyIP function is an async function, which means it returns a promise, which means you have to .catch it because you want to handle your errors. And you'll see that there's two instances of the await keyword in the function as well. At each of those points, Node is going to start executing an asynchronous operation, so either making an HTTP request or taking the HTTP response body and putting it into JSON, and it's going to pause the execution. So you see these red squares around the await calls. That's a place where Node is going to pause execution until the promise is settled. So then once await fetch is settled, then it will assign the resolved value of the promise to res, and then it will print it out after the second the res.json promise has resolved. So yeah, async await is a very, very powerful, very elegant syntax, but it's also not quite as easy as it looks. It has kind of a learning curve where you think everything is easy, everything is beautiful, and then all of a sudden you dip down into the valley of despair, and then it takes a little while for you to dig yourself back out of it. So there's kind of three things that you still need to remember when dealing with async await. First, you need to master promises, because async await, like Tyler quite so eloquently put it, it's all just syntactic sugar on top of promises. I like to think of async functions as just as a way of composing promises in very sophisticated ways. And under the hood, it's all still asynchronous, so you still need to be aware of the event loop, especially if you're writing code that might have multiple async functions running in parallel. And finally, you still need to handle errors, which is async await makes it a lot easier to handle errors, and I'll show you a little bit about how async await makes error handling much easier, much cleaner than it would be in a language like Go or Java. But you still need to be aware of all these things, otherwise you'll be struggling with my something that I need to register trademark before people start blogging about it is async await hell. It's going to start happening. First there was callback hell, then people started having promise hell, and before you know it, there will be async await hell too. So overall overview of this talk, going to be focusing mostly on fundamentals and kind of building up the macro from the micro. So talking about kind of like the real nitty-gritty details of how async await works and how it works based on the ECMAScript spec. So I won't really be talking about, say, whether or how you would use async await with, say, React or Redux or Vue or Angular 2, but hopefully I'll give you the tools to be able to answer that question for yourself. And I'll try to focus as much as possible on like as little information as possible, but the information that is most valuable to kind of the most broad use cases for async await. So trying to not get too dug into any one particular framework or any one particular library. And all these code samples available on my GitHub page. They all run, or I ran them all on Node 8.2.1, so they should all work. And without further ado, let's just get started on a little overview of promises. So again, async await is just a tool for composing promises. An async function is a special type of function that returns a promise, and await pauses execution on a promise. So one little detail is if you use await on a non-promise, it won't do anything. So it'll just give you back the value that you used. So here you can await on the string hello world, won't throw an error, but it also won't really do anything useful. It'll just give you a variable with value hello world. So what is a promise? Well, a promise is basically a state machine with 3 distinct states. It starts out in the pending state, which basically means there's an async operation that's in flight that will settle at some point. And then it can transition to either a resolved state with an associated value or a rejected state with an associated error. And the combination of either resolved or rejected is known as settled. So any promise that is not pending is considered settled, either resolved or rejected. And once a promise gets to either resolved or rejected, it can never change. So it always either resolves to exactly one value and it's resolved to that one value for all time, or it's rejected to one error for all time. So here's on the right-hand side, you'll see how you can create a promise that resolves after 1 second to an empty value. This is something that we'll see an awful lot because this is also how you kind of pause execution or do a sleep in async await. But one thing to note that's very important about promises in the context of async await is that promises handle state entirely internally. So this promise constructor takes in the executor function, which takes in 2 functions itself, resolve and reject. And when resolve is called, the promise transitions to resolve, and when it calls reject, the promise transitions to rejected. So async await can only react to changes in the promise state. It has no impact on what the actual promise itself is doing. So all async await does is just react to these state transitions. So here's one example of using await in kind of a more sophisticated way with creating a new promise. Tyler talked a little bit about promisifying Node APIs. Well, here's a little example of that. So you're going to await on a new promise, and that promise takes an executor function, which in turn takes 2 functions as parameters, resolve and reject. And this function is going to use the native Node FS module, which is famously not well integrated with promises, but has a callback-based API. And you're going to, within the promise itself, you're going to use the callback style API to read a file, which happens to be this file, the file that contains this JavaScript code. And when the callback is, or when read file calls this callback, you'll either reject with any error that occurred or resolve with the result. And this script will actually print out its own source code, which is pretty cool. But yeah, one neat thing to remember, or one neat caveat of the fact that async functions always return promises, is that you can await on another async function. So in this case, similar to the previous example where you wanted to print your own IP address, in this case, you're going to refactor out the call that actually, or the actual fetch call into a separate function called fetch as JSON, which will take in a URL, fetch that URL, parse it into JSON, and then return the result. And now you'll notice that this function print my IP actually calls this the fetch as JSON function, which is async. But of course, since async functions return a promise, you can await on a async function call. And if you want to get really fancy, the letter of the law in the ES6 spec, or the ES 2017 spec, I'm going to get confused about the years all the time. The letter of the law basically reads that you don't necessarily need to await on a promise. You just need to await on an object that has a property then, which happens to be a function. This is probably a result of the fact that that long before ES6 was adopted, and long before JavaScript had promises as part of the language spec, there was a lot of userland promise libraries like Bluebird and stuff that were very popular. So in order to integrate with these, the language spec made it so that any object that happens to have a then function is game for async await. So you can use async await easily with Bluebird or RSVP or WhenJS or pretty much any of the more esoteric promise libraries out there. And worth mentioning the difference between a promise and a thenable. Strictly speaking, a promise is an instance of the JavaScript language promise spec. So there's kind of a class that's defined in the language spec. Whereas a thenable is just a general class of an object that happens to have a then function. So you can await on any thenable, not necessarily a promise. But on the other hand, there is actually, interesting fact, there's actually no way to make an async function return a promise that isn't an instance of the language promise spec. So you can't make an async function return a Bluebird function, let's say. Ooh. And okay, so part two. There is no escaping the event loop. Every async function is still going to be asynchronous. So here's a fun little exercise. Or what do you think that this code will print? Do you think it'll print 1, 2, 3, 2, 3, 1? Who says 1, 2, 3? No one? 2, 3, 1? It's actually 2, 1, 3, but because so when you call run, the async function will start executing until the first await. And this await is kind of the vanilla async await way of sleeping for 1 second. So you wait on a new promise that resolves on a set timeout. So you create a promise that resolves on a timer within the executor function. And then after that, you'll print out 3. So basically what ends up happening is that in the first tick of the event loop, you start executing the run function, 2 gets printed out. Then you exit, execution in that function gets paused. Then you exit out of that function, log 1, and then on the next tick, the run function resumes and prints out 3. So again, if you get a thenable in await, this pauses execution in the async function, but it does not block the event loop. So the event loop will start off and will keep on running, and it will pick up other events. It will start executing other async functions. It will do what it does in the background until the fetch and the res.json functions resolve, or until those promises settle. And then this function will resume its execution. So now this is another one. This is one that will actually print out 1, 2, 3, because it will so run will start executing. It will await until the next tick of the event loop for this promise to resolve. So it'll start by executing 1, and then the next tick it will print out 2 and then 3 in the same tick. Another very powerful feature of async await is the ability to do await within a for loop or an if statement. This is one of the ways that async await allows you to compose functions, or compose promises. Because if you wanted to do, say, a conditional if statement, like conditionally execute a fetch, it would be very difficult just using promise chaining. But with async await, it's very easy. Ditto for using for loops. You can use for of, for in, all of the great language constructs that you're used to using. In this example, I'm going to execute fetch on the Yahoo stock price API in order to get the last trade price for Apple, Microsoft, and Oracle. And you can just loop over all of these tickers and execute the asynchronous call to get the last stock price. But where things get a little weird is when you try to use for each. Now, if you want to use for each with async await, very big major caveat with async await is await must be within an async function. So if you do if you do functional programming type things like .for each of ticker, you'll get a syntax error. It will actually just not run at all because JavaScript will complain that await must be within an async function. So if you want to do functional programming with async await, like doing like a .for each, it's actually kind of difficult. This is kind of the closest approximation I've managed to come up with using .map and promise.all. But I wouldn't recommend doing it, not for now, but I do have a blog post on this subject that I'll link to a little later. And in this case, even order is not guaranteed. As a matter of fact, if you run this script, I think Oracle will print out first because it just runs all of the promises in parallel. But here's another fun example of using async await for kind of a dangerous thing. Computing one Fibonacci number every tick, right? So computing a Fibonacci, the Fibonacci sequence, pretty easy. You have a for loop. You take the sum of the last two numbers to get the next one. In JavaScript, it actually becomes very easy to make this completely asynchronous and kind of make it so that it doesn't block the event loop. All you need to really do is just throw in await promise.resolve, and this basically means that you will pause execution at each iteration of the for loop and then restart after the event loop is done running in the background. So again, this is something that's actually proven very handy for us at Booster because we have a really heavy order of n to the 5 actually clustering algorithm running on our REST API in production every once in a while. And so in order to prevent that from blocking up the CPU and making it so that our server doesn't respond to requests for like 500 milliseconds, we just throw in a await promise.resolve. Then that makes it so that the server can still respond to requests while running a very slow, mathematically intensive algorithm. So eventually we'll switch off to not having that in the same process, but for now, that's kind of how things work with us. Okay, one more part to go. I know this is kind of very nitty gritty, but some very interesting stuff coming up. So async functions will always return promises, so you eventually need to .catch. You'll see in all of the examples that I've done thus far, I do things like print stock prices .catch error. That's because kind of at the very top level, every error that occurs within an async function that isn't caught bubbles up to the promise that gets returned by the async function itself. So whether there was some synchronous error, like cannot read property foo of undefined, or whether there was some asynchronous error, like a 404 on an HTTP request, that will get bubbled up to the print stock prices promise. So let's go back to this logic. Whoops. So whether there's a 404 in this fetches JSON function, or whether we get some malformed response where, for some reason results is undefined under data.query, that will all end up getting caught by this particular, by this .catch. So one design pattern that I often find myself using with async await is that unless I explicitly mean to swallow an error, I'm not going to try catch around it because I'm going to rely on the top level .catch to catch that error and handle it in kind of a common way. And also in order to integrate properly with external frameworks. So async await does let you use try catch for async errors though, so let's see how that works. So again, remember that await reacts to promise state. So far you've seen what happens when a promise transitions from pending to resolved. that means await kind of returns a value properly. If the promise transitions to rejected, await will treat that as basically throwing an error. So you can wrap this in a try-catch if you want to, and if you explicitly want to swallow this error or log it or handle it in some special way, you can do it right here. So this leads to some interesting caveats with integrating with some existing libraries. And a good example is Express, the popular web framework for Node. So in theory, you can pretty easily integrate Express with async await in a naive way. So you just have this app.get star, async function request response. You're going to set down string hello world. This server will basically send back the string hello world to any GET request. So this will work, but things get a little bit tricky when you get something like this, where let's say you throw an error in the async function itself. So what will happen here actually is that your server will never respond. It will hang forever, because Express doesn't integrate well with promises. It won't .catch on the promise return from async function for you. So you need to do that yourself. So for integrating with Express, you should make sure you wrap your async functions always. So here's an example of this wrap function, which will basically execute the function and do a .then to send the value back, or .catch to propagate the error to whatever error handling middleware you have in Express. So when you work with async await and outside libraries, you always need to remember that you need to have a .catch somewhere or a try-catch somewhere. It has to happen. You need to handle the errors. If the library doesn't handle it for you, you need to do it yourself. And this will, and if you don't handle it, you'll get an unhandled rejection in Node, which I wrote a little bit about too, but won't cover in this talk. However, some libraries have very good promise support. For example, the Mocha testing framework. That's actually enjoyed good support for promises probably since 2014, version 1.18.0. So for Mocha, what do you call it? With Mocha, you don't need any outside libraries. You don't need to think about it. You just give it an async function, and it just works. So generally speaking, what you should take away from this is that async await support is largely equivalent to promise support. So if you have a library that says, oh yeah, you could pass in a promise or a function that returns a promise, you can use it with async await. So with Mocha, yes, it will work. With Express, it won't. So that's kind of all I really wanted to cover. Wanted to kind of sum up all of the key takeaways from this talk. So number one, always remember an async function is a special type of function that always returns a promise. So you need to .catch. Await is a keyword that pauses execution until a promise is settled. So if the promise resolves, you get the resolved value back. If it rejects, kind of looks like throwing an error. And that error might be an asynchronous error, like within JavaScript. It might be an asynchronous error if say some HTTP API somewhere returned a 404. Might be a syntax error if you're using eval, but you will get that error. And then await must always be within an async function. You can't nest it underneath, say, a arrow function with for each or something like that. And always, always, always be wary of unhandled rejections. Eventually, you need to call .catch, because again, all async await does for you is compose promises. So you need to at the top level do a .catch on your promise. I'll be sharing. I have these slides up on Twitter and SlideShare. But these are a lot of blog posts that I wrote that are related to async await. So guides to async await, functional programming with async await, unhandled promise rejections in Node, and integrating with Mocha Express and Mongoose, my MongoDB ODM. So slides are available here. I will tweet them shortly. And finally, Booster, we do on-demand gas delivery for thousands of vehicles in the Bay Area and Dallas, Texas. And we're hiring back-end focused Node.js devs. So if you want to, if you're interested in working with us, working on some very cool, very interesting logistics problems, try reaching out to us at trybooster.com/careers. So thank you guys very much for listening. Hope you got something out of it. And time for